Okay, for the second part of this assignment, or second part of this lesson, is we're going to talk about what do you do when there's no horizontal asymptote. So domain, vertical asymptotes, horizontal asymptotes, everything from the first session that we learned is still the same, okay? We're going to talk about when there's no horizontal asymptote. That means you're going to have a slant asymptote. And a slant asymptote is still going to be y equals, so this is going to be like a diagonal line. How you're going to find that is you're going to take the numerator divided by the denominator using long division. So we talked about where we use synthetic division now. Now we're going to talk about how we use long division again. So things that we're doing in the beginning part of chapter 2 are now coming up again. So we're going to do 3 examples of what we're going to do when there's a slant asymptote. Okay, if you didn't get all this written down, you can always pause the video. Okay, domain and vertical asymptote, horizontal asymptote, exactly the same thing as part 1. So to find the domain, we set the denominator equal to 0. And we solve, that's already solved, so their domain is all reals except that number. So my domain is all reals except 0. Which means my vertical asymptote is x equals 0. Okay, now when I go to try to find my horizontal, I look at my degrees. Well, this time the degree on top is 2, the degree on bottom is 1. So the degree on top is bigger than the degree on bottom, so that means there's going to be none. And there's going to be none on this whole section. So your 51 through, I think 56 is what I assigned. Those all do not have a horizontal asymptote. So we're going to have to find what the slant asymptote is. And it's always going to be y equals, because it's a diagonal line. Okay? And how we're going to find that is we're going to do long division. So I'm going to have the numerator on the inside. So x squared plus 0x plus 5. And I'm going to have my denominator on the outside. So x plus 0. So x, go to x squared, so what times x gives me x squared? That would be x. So if I multiply, x times x is x squared. X times 0 is 0x. Then I subtract when I go down, so minus, minus. These both cancel, and I'm left with 5. Okay, on slant asymptotes, we do not care about the remainder. So this is my slant asymptote, y equals x. Okay, it just happens to be the same number, same thing on bottom. That's not always going to be the case. Okay, that's lucky on this one. Okay, so when I go to graph, I'm going to do my asymptotes and dashed lines again. So my vertical x equals 0. I would have a dashed vertical line at 0. Okay, then my slant asymptote, that's in slope-intercept form. So I start at 0, my slope is 1, so up 1, right 1, up 1, right 1. This is my dashed line. So when we're gonna plug in points in just a second. When we plug them in, the same rules are going to be true. Whatever my points are gonna have to be inside the dashed lines. Depending on where your points are, these are still the barriers that are going to keep your points in play. To get your points, you're still going to do like what we did on yesterday's. So I'm still going to pick 2 points bigger and smaller, so greater and less than your vertical asymptote. So I'm going to plug in for the greater than 1 and 2, for the less than -1 and -2. Excuse me. So when I plug in 1, I would get 6 on top divided by 1, which is 6. Then I plug in 2, that'd be 4, so I get 9 on top divided by 2, which is 9/2, which is the same thing as 4.5. When I put in -1, I get 6 on top divided by -1, so -6. And when I put in -2, I get 9 on top divided by -2, which is -4.5. Okay, so when I plot, the first two go together, they're going to be inside of a barrier. The next two go together inside of a barrier. So 1, 6, 2, 4.5. So when I connect these, they curve still, and they get close to your dashed line. So these are going to curve toward this dashed line like that, and then toward this dashed line. Never going to cross, but they're going to come close to it. Make sure you put your arrows on it. So then I have -1, -6, -2, -4.5. Same thing, these are going to curve and get close to your dashed lines, but are never going to cross it. Sorry. Okay, a lot of times on these problems, just like we talked about yesterday, they're going to be diagonals. A lot of times these are going to be diagonals as well. Okay, they just look a little different because instead of having a horizontal, or sorry, a vertical and a horizontal, we have a vertical and then a slant. Okay, let's do another example. Okay, so first thing I'm going to do is I'm going to find my domain, so I set the denominator equal to 0. Excuse me, so x equals 0, so my domain is all reals except 0. So that means my vertical asymptote is x equals 0. Okay, horizontal. Degree on top is 2, the degree on bottom is 1, so the degree on top is greater than the degree on bottom, so this is going to be none, which means we're going to have to find our slant using long division. So I would have, now I'm going to write this in order, so it would be -x² plus 0x plus 1, and then the outside would be x plus 0. So what times x is -x²? That would be -x. I multiply through, this would be -x² minus 0x. Subtract when you go down. This one cancels, but this one also cancels. So I'm left with 1, and that doesn't go into that, so that's my remainder. So the only thing I care about is on top. So my slant is y equals -x. Okay, so when I go to draw my asymptotes, x equals 0. So a vertical line at x equals 0. Okay, y equals -x. Well, my y-intercept would be like 0 because y equals -x plus 0. And then my slope is -1, so down 1, right 1, down 1, right 1. So this is your slant asymptote. Okay, so when I plug in numbers, plug 2 on each side of my vertical is 0, so I'm going to plug in 1 and 2, -1 and -2. Okay, so when I plug in 1, I get 0 on top. Well, 0 divided by anything is 0. So if I plug in 2, I get 1 minus 4, so -3, divided by 2, -1.5. And when I plug in -1, I get 0 on top. 0 divided by anything is 0. And when I plug in -2, I get -3 divided by -2, so this would be positive 1.5. So I have 1, 0, 2, -1.5, so we're getting close to that line. So these are going to curve close to these dashed lines. And on the other side, -1, 0, -2, 1.5. So these are curving close to those. Okay, on your directions, it also talks about like continuous and intercepts. You do not have to find those unless you want to. Okay, you can do it just like I've been doing here. I do want to know your domain, your vertical, your horizontal, and your slants. Okay, now I know all the horizontals are going to be none, so you can leave that part off if you want to. Okay, we're going to do one more. Okay, so if I want to find my domain, or sorry, I guess the exception in the domain, you set the denominator equal to 0 and solve. So I get -1/3. So my domain is all reals except -1/3. So my vertical asymptote would be x equals -1/3. Okay, my horizontal's none, is 2 bigger than 1, so I'm going to find my slant. I'm going to use long division. Let's do it down here. So I'd have x squared plus 0x plus 0 inside here. And I would have 3x plus 1. Okay, we're going to have to think a little bit because now we're going to have fractions. So, like what times 3x would give me x squared? Well, I know there's going to have to be an x. So what cancels out the 3 would be there's a reciprocal, which is 1/3. So this would be 1/3 x. So when I multiply 1/3 x times 3x is x squared. 1/3 x times 1 is 1/3 x. So I subtract, x squareds cancel, 0 and -1/3 x would be -1/3 x. Bring down the plus 0. Okay, so now we need to figure out what 3x times will get -1/3. Well, we know it's not going to be, we don't need to have an x, we need to have a number. So if you can't figure it out in your head, well, the easiest way is I'm like, okay, so what times 3 will give me -1/3? Okay, so that's what I try to think, like what times this? Well, if I want to figure out what that is, then I need to divide by 3. Well, the same thing as dividing by 3 is the same thing as multiplying by its reciprocal. So this would be -1/9. Because 3 and -1/9 if I multiply together is -1/3. Maybe if I Microsoft right there. And then negative 1/9 times 1 is negative 1/9. When I subtract, now these will cancel. So then I'm left with 1/9 as my remainder. Okay, and we don't care about remainders. So my slant asymptote is y equals 1/3 x minus 1/9. Okay, so if I'm graphing these, do the best you can with fractions. So x equals negative 1/3, that's approximately right here. Okay, then the other one, I would start at negative 1/9, and I'm going to go up 1, right 3. Up 1, right 3. Or down 1, left 3. Down 1, left 3. So my slant is close to this. Okay, it doesn't have to be perfect. Okay, so on my T-chart, I'm still going to pick numbers above and below my x. Okay, you don't have to pick fractions. I'm going to pick 0 and 1 for above, negative 1 and negative 2 for below. Okay, when I plug in 0, I would get 0. When I plug in 1, I get 1 on top, and 4 on bottom, so 1/4. When I plug in negative 1, I get 1 on top, and negative 2 on bottom, so negative 1/2. And when I put in negative 2, I get 4 on top, let's see, negative 6, so negative 4/5 on bottom. So I would have 0, 0, 1, 1/4. So this graph is inside these dashed lines. And then negative 1, negative 1/2, negative 2, negative 4/5. That's hard to see because they're really close, are inside these dashed lines. Okay, this will get you all the way through 51 through 56 on the 194 assignment.